Top students solve this problem. Let's look at the question. We're asked to calculate the result of 4 6s multiplied by 4 6s. If we try to write out the equation and calculate it directly, we might spend a long time and not get the answer. So for problems like this, we need to observe carefully. Let's see if there's a clever way to solve it. When we're looking for shortcuts, what kind of numbers do we especially like? For example, 99, 999, or 9,999. Why do we like numbers like these? Even though they're not round numbers or tidy numbers, they're easy to work with. For example, you can write them as 10 minus 1, which makes the calculation easier. This one is 100 minus 1, and that one is 10,000 minus 1. So can we turn this number into, say, 4 nines? At the moment, it definitely doesn't look possible. So the method we need to use for this problem is called decomposition. For example, these 4 6s at the beginning, I can break them down into 3 times 4 2s. Second, let's try a different way to break it down. I can split it into 2 times 4 3s. But no matter which method I use, it's always equal to the original number above. So what's the benefit of breaking it down like this? Take a look. If you do 3 times 4 3s, isn't that 9,999? That's 4 9s, right? And in the middle, I have 4 2 times 2. So let's write it out. The multiplication process, 4 2 times 2, is 4 4s. So what is 3 times 4 3s? 9,999, that's 4 9s. I've managed to get it. In what form can we write it? You see, isn't it 10,000 minus 1? At this point, we should know what to do. Just remove the parentheses and have 4 4s times 10,000. 4 digits, then add 4 zeros after it and subtract 4 4s times 1. 4,444. All right, next we'll do the subtraction. Actually, you just need to align these 4 zeros with it and subtract them one by one. So 0 minus 4. Since that's not enough, you borrow 1 from the next digit. So it's actually 10 minus 4. So it should be 6. Now, since this 0 had to borrow 1, it also needs to borrow 1 from the digit before it. So for this digit, subtracting 4 is actually like 9 minus 4, right? So that should be 5. The same logic applies to the 2 zeros before as well. All right, moving on. Now, when we get to this digit, it needs to borrow 1 from this 0, as you can see, so it should be 3. The 3 4s in front remain unchanged. Just bring them down, and that's it. This question tests efficient calculation methods.